Okay, now next here, that's what I'm going to deal with coordinate systems. Means what are different kinds of coordinate systems which we use in electromagnetics. Okay, and why we use you know different kinds of coordinate systems. Okay, means in electromagnetics, whatever quantities we deal with, so those quantities are at the are time and space dependent. It means these coordinate systems help to locate any particular point in the space, okay, and the direction of the vector also. Clear? So that's why we use different kinds of coordinate system. So there are particularly two kinds of coordinate systems. Okay, I think I should erase this one. So here I can write down the name of the coordinate system. Okay, so that is orthogonal coordinate system. So what it is this orthogonal means? Orthogonal coordinate systems are those coordinate systems in which we can see unit vectors are perpendicular to each other. Okay, so in such you can say the coordinates are mutually perpendicular. So whatever coordinates we use in this coordinate system, so those coordinates are perpendicular to each other. Okay, and in case of non-orthogonal coordinate system, now there may be possibility that those coordinates are not perpendicular to each other. So non-orthogonal coordinate systems we use for specific purposes, not to deal with the general kinds of problems which we face in day-to-day life. So that's why we uh, are going to deal with orthogonal coordinate system. So under this orthogonal coordinate system, so particularly three kinds of coordinate systems I will deal with. The first one is Cartesian. So about this one you are already familiar. First one here, it is the Cartesian coordinate system. The second one here, cylindrical coordinate system, and the third one given spherical coordinate system. So what kind of coordinate system it is better to use, that depends on situation. Means what kind of quantity you are dealing with, and which one it is better to suit in that particular situation. Situation to situation, we will use different kinds of coordinate system. Sometimes we will use Cartesian coordinate system, sometimes we will use cylindrical, sometimes we will use spherical coordinate system. So it depends on the situation and how you are dealing with the problem and what kind of problem you are dealing with. Okay. So the first one, here it is Cartesian coordinate system. This Cartesian coordinate system I used to explain some basic laws related to vector algebra. So I think a lot of familiarity with this coordinate system you already have, but yet some details I will explain you. Okay. So the first one here, Cartesian coordinate system. So what is this one? So here three axes perpendicular to each other. Okay, so here we can write here it is anything you can write on. So here I'm writing y, then z, and then here x. Okay, and then in this one, if you have like this, okay, so I will explain you. First of all, let me draw this one. So now you can see here this one. So here one cube I have drawn so that you can understand different frames. So if you drop a projection from this point, so that is dl, so that is differential length. Okay, this here is nothing but the differential length. Okay, so if you draw projection in the xy plane, so now you have, and then accordingly now this is it. So now along y-axis you have dy, that component means the component of this differential vector along x-axis, and sorry, along y-axis that it was, and in the same way you have the component along x-axis and along z-axis also. So here you can write dz. So along these three axes, so you got the component of differential length. Here one length, you can say if you have a length and out of that if you take a part of that length, then that can be called as differential length. Okay. So this differential length can be represented, this dl can be written as, or dl vector can be written as x cap dx plus y cap dy plus z cap dz. Okay, so that it is about the differential length. Clear? So what about the surface? Means differential surface and differential volume. Okay, it may be possible now if you have a surface. Okay, now you have a plane. Now out of this whole plane, if you take a part of this surface, then that can be called as differential surface. Okay, and how we can get that differential surface? So that's I will show you. And so now here we have d s y. Okay, differential surface, and that can be represented by y cap, and then it will be dx dy. It means here whatever it is the differential surface along y-axis, that can be represented by dsy, and that is nothing but the product. Now along this one, it means whatever it is the length, means what is the area, so that can be this one. It is wait, sorry, here it should be z, not y. Here it should be z. Okay, so this part here it is along z-axis, means vertical it is z-axis, and horizontal that it is x-axis. So that's why these two components, so dx and dz multiplied, then you got the surface. Okay, surface, this differential surface you got, and this dy cap, sorry, not dy, y cap. So this y cap is representing the direction of this differential surface along y-axis. Okay, in the same way we can get differential surface for this one also. So here you have the direction. So in this case, in which direction it is coming? It is coming in the along x-axis. So here we can write on d s x equals, so x cap and then dy and dz. So here the product of dy and dz, so differential we are taking, and then the cap, x cap we are taking here. Okay, so this x cap, it is showing the direction of this differential surface. It is in the direction of x-axis. In the same way, we can see here dsz, so that will be along z-axis. So dsz can be written as, and since it is along z-axis, so the unit vector, so z cap we are going to use, and the surface can be, now you can say this side, it is the y component, so that's why we can write down dy, and this component, or you can say this side, it is the z component, sorry, x component. This one it is x component, okay, because it is along x axis. So now you can see whatever here you have now, so that much you have, this much it is dimension. Okay, it is just above this surface. Okay, so this q, it is above xy plane. So you have x axis, y axis, and now you have the plane, and above this plane you have this q. Okay, so that's why whatever it is the value dx, so that it is representing this part. Whatever it is the value dy, that it is being represented for this one. Okay, so and whatever it is the value of z, so that it is the vertical side. Okay, so differential surface you got. Now in the same way you can get the differential volume also. Okay, so now ds y, if you take ODF, now you can say first dsx. So if you take dsx and differential surface along x-axis, so that it is present in yz plane. Where it is present? So here you can write down yz. So yz plane. So this one it is present. This dsx means the differential along x-axis, that is present in yz plane, and in the same way this differential dssz means differential along z-axis, that it is present in xy plane. So here it is in xy plane, and the differential along y-axis, that it is present in zx plane. So that what I can write on here, xz plane. Okay, so this is the way how we can get differential, so whether it is differential length or differential surface. So here we got differential length, and here we have differential surfaces. Okay, in the same way we can get differential volume also. So again, differential volume is simply if you multiply, or if you can get the product of differentials along three axes, then you will get differential volume. So here I can write down this differential volume, that it will be equals dx into dy into dz. So these things are all about Cartesian coordinate system. So these concepts are very useful. Later on I will explain you how these systems are useful to visualize different phenomena related to electromagnetics. And you already know that electromagnetics, concepts of electromagnets we use in many fields, just like when we deal with electrical machines, or when we talk about telecommunication system, just like different kinds of wireless systems. So in those situations, I will explain you how these coordinate systems are going to be used for different kinds of mathematical calculations related to those things.